So, alright guys, so we are going to be talking about residue of calculus. We've talked about Lorentz series, and right now we are going to be discussing residue of calculus. Alright, but before we start anything, so I want you to master the formula for the nth term of residue of calculus as residue f of z, then z naught to be equal to lim of z tends to z naught. So where you have your 1 over n minus 2 what into this d raised to power n over d of z raised to power n minus 1, then you have z minus z naught raised to power n, then f of z the z. So that is the residue of calculus formula. So we have to master that. Alright, we have this question. It said, question 1, find the residue of f of z is equal to 1 over z squared plus 1 divided at z equals to 1. Alright, so that is it. So now, this is our question. So if you want to find the residue of this, now one thing is that you have to find a way to reduce this f of z. That is the first attack we should give it. So from this place, you know, when we want to find our, you know, this analytic function now, it is having degree of 7. The degree is 7. So we need to find what? You need to find, it's having order of 3. That's what I mean. It is having order of 3. So sorry, I said another thing. So this analytic function is having order of 3. So how do we find our pole? So the way you can find a pole is, you just, to express this one in a simpler form, the first step is that take out what you have here, put it equal to 0 as if they are finding the pole. So that's z squared, take what? Z squared plus 1 is equal to what? Is equal to 0. Okay? So, which implies that z squared is equal to what? Minus 1. Now, at the same time, this one is the same thing as plus what? The same thing as plus or minus square root of what? Minus 1. Alright? So, which is also the same thing as z is equal to plus or minus, you know, square root of minus 1. This is an imaginary number. Okay, so when you're having this one becomes what? I. So you're having plus or minus I. By the time you bring this one back, it implies that z is either you have z plus I or what? Z minus I. Alright, so at the end of the day, that is what we are going to be having. Alright, so we are going to be having z plus I or z minus I. Do you know I came about this? So which means that this one is either z equals to plus I, or you can just write I, then z equals to minus I. If you take this one back, you have minus I. If you take this one back, you have plus. That's how I arrive at this. So at the end of the day, which means that this one becomes what? F of z equals to 1 over. So this one that we brought out is still the same thing as this. Don't forget, it was the one we interpreted to this guy. So we put it back into the bracket, having what? Z plus I, then z minus what? I. So, alright. It is all carrying what? Cube. Are you with me? So we now have what? The expression in the form was 1 over. This one now be z plus I all carrying cube, z minus I all carrying what? Cube. Z equals to what? I. Let's start with that one. At z equals to I, let's see what we got. You know, we're having plus or minus I. We're having plus or minus I. So at z equals to I now, let's find the residue. So our residue is equal to f of z, then I is equals to, we are substituting I because our z naught now is the first z naught now is I. So we are substituting this first one here. So equals to lim of z tends to what? I then we are using that formula 1 over our n. What is our n? Our n is 3 because it's having order of 3, so the order is your n. So our n is 3, that's 3 minus 1 factorial, then into the differentiation, that's d raised to power 3, d raised to power n minus 1, then over the z raised to power, so this is d raised to power 3 minus 1, then 3 minus 1. So we are having what? Our z minus, what is our z naught? Our z naught here is I, alright, raised to power 3. Then what is our f of z? We are applying that formula. Our f of z is 1 over z plus I cube. This one that we expressed here, then z minus I cube. So that is it. So we are just substitution. Once you know what you are doing, it's just substitution. Okay. So now this guy, take care of this guy. Alright. So as long as we are having what? Our residue to be f of z, comma I is equals to lim z to what? To I, then 1 over 2 factorial. Alright. Then this one becomes d square over the z square. Okay. So we are left with 1 over z plus I. Alright. So at this junction we have this guy right here. Alright. From this side, so you are going to differentiate this one twice. That's how you can apply this. But regardless, here we have what? Our residue, then our analytic function I is equals to lim z times I. This one is 2 factorial is 2. So we are having 1 over 2 into, let us differentiate this. For instance, we are having 1 over z plus I is per 3. So like, I think I have a final answer to differentiate this one. So don't just test ourselves. This one is the same thing as z plus I is per minus. I think I should explain it. This one is the same thing as this in index form. So you just bring this one out. That is minus 3 into, differentiate what you have here with respect to z. You are having what? 1. Then z plus I is per minus 3 minus 1. So that is minus 3 into what? Into z plus I is per minus 4. Alright, so no stress. So at the long run, this one becomes it reduced to d over the z into what? Into minus 3 z plus I minus 4. Alright. So we are going to differentiate it again. And then we differentiate this guy. Let's differentiate this guy again. So actually this one comes back. This becomes residue. Okay. Let's continue like this. It becomes the residue of the analytic function to I, then equals to lim z to z naught. I mean z to I. Are you with me? Z naught to I. Okay, z to I rather. Then we are having this one comes out because it's a constant. Okay, so we can gladly bring it out. We can bring it out. That's minus 3 over 2 into what? Into d over dz. Then z plus I is per minus 4. Alright. So at this junction we have lim z to I z, no worry, z. Hello Alpha, mo ṣe ń ṣe fídíò lọ́wọ́, mo fẹ́ parí ẹ̀. Jọ̀ọ́, mo ṣe ń ṣe fídíò lọ́wọ́, mo fẹ́ parí ẹ̀, máa pè padà. Yeah. Wàhálà gẹ̀ ipò. Alright, so we are having 3 over 2. 3 over 2. Don't forget there's a minus here. So by the time we differentiate this guy, it becomes minus 4 into 1 z plus I raised to power minus 5. Alright. So we're having minus 4. Minus and minus is plus. So and then that 4 times this one, it becomes 12. So we're having 12. Then we're having z plus I raised to power 5. Alright, so that's it. Raised to power minus 5. Alright, so this one take care of this one. We are having what? Lim z to I then 6 into z plus I all raised to power this guy. So we are having, anywhere you see z, you put, anywhere you see z, you put I. So you have what? Lim 6. I mean, there's no more lim there. 6 into I plus I. Alright, raised to power minus 5. So we are having what? 6 into 2I raised to power minus 5. Alright, so which implies that we can also have 1 over, this is 6 into bracket 1 over 2 raised to power 5 I raised to power 5. Are we together? So which is the same thing as 6 over 2 raised to power 5 is 32. Alright, if you agree with me, times I raised to power 5. So what's our I raised to power 5? Our I raised to power 5 is I times I is what? I times I is 1. I times I is 1. This, there will be the remaining I, that's I. So we are having I as 6 over 32I. So it is not appropriate to leave our answer like this. So this I, if you want to bring it up, I is the same thing as minus I over 1. Like, sorry, I mean 1 over I is the same thing as 1 minus I over 1. So to take this I up, it becomes minus I minus 6I over what? 32. You can reduce it. Alright, 2 will go here and 2 will go here. 2 here 3, 2 here 16. Alright, so we are now having 3I minus 3I over 16. So that is the first one we are having. We are having minus 3I over 16. So we're not done. So we can also solve for what's it called? We can also solve for this one. We are going to solve for z equals to, oh sorry, we have to follow the rule of the question. They said find the residue of f of z at z equals to I. But in a case whereby they just ask you to find the residue, as mean they just say find the residue, that means you have to solve for it. You are having 2z here. You are having z equals to I and you are having z equals to minus I. So since they specified for us to find the residue of this calculus at z equals to I, so you have to limit what you are solving to I. So as for you that you are watching this video, so I would like you to find the residue of this analytic function at z equals to minus I, and let me know what will be your answer. Then drop your answer in the comment section. Let me just give you a clue. How we are going to solve this one is that the residue, this same formula is applicable. The residue formula is f of z, okay, comma z naught, then equals to 1 lim z tends to z naught, then 1 over n minus 1 factorial into d raised to power n minus 1 over dz raised to power n minus 1, then z minus z naught raised to power n, then f of z. So this, using this formula, so at z equals to, for instance, at z equals to I now, so this one you write it as residue of f of z comma minus I is equals to lim of z tends to minus I. Alright, then we have 1 over, you know your n is the degree, is the order is 3, that's 3 minus 1 factorial, then d raised to power 3 minus 1, as usual, d z raised to power 3 minus 1. So then this one is z, you know, if you substitute this one, which is minus I, it will become plus. So that will be z plus I raised to power what? 3. Then your f of z, 1 over z plus I cube, z minus I cube. Then this one z minus I cube. So this one cancel this one, then you are left with this one. Then you rewrite what you have outside that. Lim z tends to minus I, then 1 over 2, then d square over dz square. Then we now left with 1 over z minus I raised to power 3. Then from here you can continue what your residue will be. So after you continue what your residue will be, so you now help me find, okay, in the next video let's stop here. So solve this, continue from here and drop what will be answer in the comment section. Don't forget that 1 divided by I is equals to minus I over 1. Alright, so it is always wrong when you are having your I and attached with the numerator of the final answer of your residue. So in the next video we'll be talking about Cauchy residue. We'll be talking about what? Cauchy residue. So God bless you. If you find this video, if you drop a comment, give me a thumb and share. Love you. I like to talk.